Welcome to this explainer. Today we're going on a deeply visual journey, starting way zoomed out at the macro fundamentals of the web and zooming all the way in to senior-level CSS architecture. Whether you're literally writing your first line of HTML today or you're a seasoned pro wrestling with some nightmare layout, there's actually something really profound about stepping back to see the whole system. We're going to look at exactly how we control the web, right from the global network level down to painting a single pixel on your screen.
Real quick, here's our roadmap. We'll map the web's evolution, look at the client, server, and HTTP, cover the birth of CSS, dive into the literal physics of the box model, master layouts and positioning, and wrap it all up with the ultimate CSS quiz. Let's get into it.
Section 1. The web's evolution, from static documents to decentralized data.
So, starting way back in 1990, Web 1.0 was just this static era. Read-only HTML, where we just consumed flat documents. Fast forward a bit to the 2000s, and Web 2.0 kicked off the social era. Suddenly, with stuff like Ajax, pages could update dynamically without reloading the whole thing. People could actually interact and contribute in real time. And now? Well, now we're in Web 3.0, the semantic era, which is all about decentralized, machine-readable data.
It's a massive transition. We went from essentially flipping through digital paper to building these incredibly vast, interconnected, intelligent applications. We really aren't just building web pages anymore. We're architecting deeply complex software that lives entirely inside your browser.
Section 2. Client, Server, and HTTP. The foundational handshake. Take a look at this underlying architecture. Over on the left, you've got the client. That's your web browser, constantly demanding resources like HTML, CSS, and JSON. And on the right, the distant server, sitting there storing data and crunching the heavy logic. The wild part about this is that these two totally separate machines coordinate everything they do just by firing simple text-based messages back and forth across the planet.
Now, the absolute crux of this relationship is statelessness. And honestly, this concept trips up beginners and seniors alike. By default, the server suffers from total amnesia. It doesn't keep any session data between your requests. So every single time you interact with the web, you have to package up all the context needed for that interaction, because the server simply won't remember what you told it 5 seconds ago.
Because of that setup, we run into the massive headache of concurrency. You've got millions of programs executing simultaneously all over the world, with zero global clock to keep them perfectly synced. That means we have to rely on asynchronous coordination. And as developers, we constantly have to design our apps to handle partial failure states. It's basically organized chaos.
So how do we reliably communicate our state and intentions across this wildly unpredictable network? We use HTTP methods. It's the universal vocabulary of the internet. You use a GET request to read or recover a resource, POST to create a brand new one, PUT or patch to modify something that's already there, and delete to, wipe it out entirely.
Moving on to Section 3, the birth of CSS in 1994 and separating content from presentation. The final web page you see rendered on your screen isn't just a list of top-down commands. It's literally an ongoing argument between the browser's default settings, the user's personal preferences, and the styles you, the author, wrote. The cascade is essentially a giant negotiation funnel that continuously resolves all these conflicts in real time. To actually get a word in during that argument, we write style rules. They're built exactly like this. You have a selector targeting a specific element, let's say an H1, followed by a declaration block. Inside that block, you declare your properties, like color or font size, and pair them with their specific values. But what happens when those rules inevitably clash? Because in a large code base, they absolutely will. Well, the browser consults the specificity ladder to crown a winner. It starts at the very bottom with those weak universal selectors, climbs up to element tags, then classes, and goes all the way up to those highly specific ID tags at the very top. Truly mastering this ladder, that's what separates the junior devs from the seniors.
Section 4. Physics of the box model. Defining our visual vocabulary.
If there is one fundamental truth of the web, it's this. Every single element on your page is an invisible box, period. And its total physical width on your screen is strictly calculated by adding together its core content width, the inner padding, the border, and the outer margin. Seriously, if you don't respect this math, your layout's going to break every single time.
To actually size these boxes, we have to pick our units carefully. Back in the day, we relied heavily on absolute units, exact, rigid pixels. But modern CSS architecture, it strongly favors relative units.
We're talking percentages, viewport heights, and root relative units like rems. Doing this gives your interface scalable fluidity, meaning it gracefully adapts to literally any screen size.
All right, Section 5, Layouts and Positioning, taking total control of the viewport.
The evolution of layout engines is basically a survival story. We literally went from the absolute duct tape of using HTML tables in the 90s to hacking CSS floats together in the 2000s until we finally arrived at the rigorous, super powerful architecture we use today, Flexbox and Grid.
And that whole evolution unlocked the magic of responsive design. Now, using a single codebase and some clever media queries, we can fold, squish, and reconfigure our content across desktops, tablets, and mobile phones, all without ever touching the underlying HTML structure. It's pretty brilliant.
Then, for that ultimate pinpoint precision over an individual element within your layout, we rely on CSS positioning. You have to decide its exact behavior. Do you want it relative to its original spot, absolutely pinned to its parent container, fixed to the viewport so it literally never moves as you scroll, or sticky so it perfectly catches at a certain point?
And finally, Section 6, the ultimate CSS quiz, Trial by Fire.
Now, as the source material points out, trying to learn CSS via a quiz is dangerous territory. The cascade can be absolutely unforgiving. But don't let it crush your spirit. Let's see if you've really leveled up from beginner to senior today.
Here's your first rapid-fire challenge. Think back to our chat about layout flow just a second ago. Out of all those complex ways we can position an element, what is the default position value right out of the box? Is it absolute, fixed, relative, or static? The answer is static.
Okay, last one, the ultimate senior-level gotcha. Let's say you tell a box to be 100% height, but its parent container has absolutely no defined height. What happens? Does it fill the whole screen or just throw an error? Actually, it completely collapses to auto, and that leaves us with a pretty terrifying final thought. If just one missing parent height can silently collapse your entire layout, how many other hidden architectural rules are silently breaking the code in your current projects right now? Keep learning, keep experimenting, and I'll catch you in the next explainer.